Welcome to our fifth lesson under statistics and probability, and it's all about computing probabilities corresponding to a given random variable. So our lesson objectives for this lesson, so you are expected to, at the end of this lesson, you're expected to first determine probabilities of a given random variable and compute probabilities corresponding to a given random variable. So let's think about this. Many events can't be predicted with total certainty, of course. Do you know what will happen tomorrow? For example, if tomorrow is election day, do you know who will win? Or for example, do you know when will COVID-19 end? So there are many events that can be predicted with total certainty. So the best way we can say is how likely are they to happen using the idea of probability. So the idea of probability is very helpful when determining what are likely to happen. Example, in when you when you join in a contest and there are only 5 of you who joined in the contest, then what is the probability that you will win? So there are a lot of probabilities that we can apply, or there are a lot of situations where we can use the idea of probability. So we use probability in finding the chance that, example, heads will appear. We use the probability in finding the chance that heads will appear when tossing a fair coin, the likelihood of winning in a lottery, and in some other game of chance. So mostly we can use the idea of probability in the game of chance. Example, we have here events. In a table, we have here events and its corresponding probability. So try this. You can get a piece of paper and try to determine the probability. Example number 1. So event number 1, getting an even number in a single roll of a die. So when you roll a die, what is the probability of getting an even number? So this is our random variable. What do you think is the probability of getting an even number in a single roll of a die? We have the probability. Find the probability of the event. So let's have here the event number 1. We will determine the probability of getting an even number. So when you roll a die, of course, the possible outcomes that you will get, it's either one spot, 2, 3, 4, 5, and 6. So what do we do next? What will we do next? First, from these possible outcomes, determine what are the even numbers or the even spots. So we have here the even spots here are 2, 4, and 6. So how many even number or even number of spots do we have from our possible outcomes? So of course, we count them 1, we have 2, and 3. So we have 3 events of 3 chances of getting an even number. So our probability would be 3 because we have 3 number of even number, 3 events of getting an even number. So it is either 2, 4, or 6 out of 6 possible outcomes. So the probability of getting an even number in a single roll of a die is 3/6 or 1/2. So if we express this in a decimal form, we will get the chance or the probability of getting an even number is 50% because half of the possible outcomes are even number. Okay, next. Another one, number 2. Let's try this. Getting ahead when tossing a fair coin. Suppose your coin is fair. So sometimes there's a coin na gupi-gupi or something hindi siya fair. So getting ahead when tossing a fair coin. So what is the chance or what is the probability of getting a head when tossing a fair coin. So the possible outcomes, when you toss a coin, it's either you will get head or tail. So duwa lang man ang pwede matabo, mag-toss ka ka coin. So it's either you will get head or tail. Of course, since we only have one head, out of the two possible outcomes, the probability of getting a fair coin is 1/2, 50%. If you try to get, if you try to determine the probability of getting a tail, it is still 1/2 because um, each of them have each of them has equal chance of appearing because only two of them there are only two possible outcomes, so we have 1/2. Next, getting a number greater than 4 in a single roll of a die. So let's have another situation in a die wherein the event that you want to get is a number greater than 4 in a single roll of a die. So what is the probability that when you roll a die, you will get a number greater than 4? So we will determine from the possible outcomes what are the number of spots which are greater than 4. So from our possible outcomes, still we have 6 possible outcomes, up to 6. So we will determine from these 6 possible outcomes what are the possible outcomes which are greater than 4. So we have 5 which is greater than 4 and 6. So out of 6 possible outcomes, we have two chances of getting a number greater than 4. So the probability of getting a number greater than 4 in a single roll of a die is, what do you think is the answer? So it is 2, since we have two numbers which are greater than 4, so 2 out of 6, or reduced to a simplest form, or 1/3. So we have 1/3. So this is the probability of getting a number which is greater than 4. Next, how about getting a 10 when a card is drawn from a deck? So I know you're familiar with cards because some of you are playing cards. So when getting so the event here that we are trying to finding the probability is getting a 10 when a card is drawn from a deck of cards. So the possible outcomes, how many cards are there in a deck of cards? So in a deck of cards there are how many cards do we have in a deck of cards? So think this, if you count them all, this is 54. So we have 1, 2, 13. So 13 times 1, 2, 3, 4. 13 times 4. So 13 times 4, we have 52. So not 54, but 52, 52 deck of cards. So 52 cards, 52 cards. So we have 52 cards. Out of 52 cards, what is the probability or the chance? What is the possibility or the probability of getting a 10 when a card is drawn from a deck of cards? Mabunot ka sa deck of cards. So, pilaihan a porsyento, or what is the probability that you will get a 10. So, out of 52. So, first, we will determine how many cards which are 10, how many cards are there in a deck of cards which are 10. So, we have here, there are only four cards which is 10. So which is labeled as 10. So you have there 4 cards. If you have 4 cards out of 52 cards from a deck of cards, what is the probability of getting a 10? What do you think is the probability? So we have 4, since we only have 4 10 cards from a deck of cards. So 4 out of 52, or 1/30th. reduced into lowest term. How about getting a 7? Of course, it is also 4 out of 52 because we have 4 7 cards in a deck of cards. Next, so this next is getting a sum of 6 or a sum of 10 when 2 dice are rolled. So this is much harder or much. So example, getting a sum. What is the probability that you will get a sum of 6 or a sum of 10 when 2 dice are rolled? What is the probability? So first, we will have getting a sum of 6. Again, from the possible outcomes, when rolling a die, we have here 2 dice. So 2 dice. So we have here getting a sum of 6. So when you roll a die, these are the possible outcomes. So you have there 36. This is 6 times 6. So 36. 1, 2, 3, 4, 5, 6. 6 times 6, 36. So you have 36 possible outcomes. So example, when you roll a die, when you roll 2 dice, you might get 1 spot, 2 1, 3 1, 4 1, 5 1, and 6 1. On the second column, you might get 1 2, 2 2, 3 2, 4 2, 5 2, 6 2, so on and so forth. Now, we will identify from these possible outcomes, we will identify those outcomes whose sum is 6. So we have here, first is 5 and 1. 5 plus 1 is 6. Another one, sum of 6 is 4 and 2. Another one, 3 and 3, 2 and 4, and also we have 1 and 5. So how many outcomes, how many possible outcomes do we have with a sum of 6? So we have 1, 2, 3, 4, 5. So we have 5 outcomes out of possible outcomes with a sum of 6. So what is the probability of getting a sum of 6? That is 5 out of 36 possible outcomes. So this is just the sum of 6. How about the sum of 10? We will identify then the sum of 10. So again, from the possible outcomes, we will identify what are those possible outcomes with a sum of 6. When you add them together, you will get a sum of 6. So we have 6 4, 5 5, 4 6, and nothing less, nothing more. So you have 6 4, 5 5, and 4 6. So out of 36, we only have 3 possible outcomes with a sum of 10. So we have 3 out of 36, or rounded off to nearest to the simplest form, is 112. So this is the probability of getting a sum of 10. Now the event is getting a sum of 6 or getting a sum of 10. What do we do next? So you will have this, the P, the probability, sum of 6 or sum of 10. So we will have this formula, number of pairs with sum of 6 divided by total number of outcomes plus number of pairs with sum of 10 divided by the total number of outcomes. From the previous lesson, or from the previous slide, the sum of 6, the probability of getting the sum of 6 is equal to 5 out of 36 total outcomes, and the probability of getting a sum of 10 is 3 out of 36. So adding up these two fractions, we will get, since they are similar fractions, simply add the numerator and copy the denominator. So we will get 8 out of 36, or 2 ninths. Or you can still divide it, 2 divided by 9 to get the decimal form of this fraction. So The probability of getting a sum of 6 or a sum of 10 when 2 dice are rolled is equal to 8 out of 36 or 2 out of 9. You get it? I hope you follow and you got the correct answers. So we will try to explore this. Example number 1. The demand for laptops in the new normal. So the daily demand for laptops in the new normal in a computer store is the probability distribution as follows. So you have there a table with the number of laptops as our random variable represented by x. And we have the probability or P of x. So we have there the number of laptops such as 5, and its probability is 20 hundredths for 6. We have 12 hundredths for 7. We have 15 hundredths for 8. We have 18 hundredths for 9. We have 25 hundredths for 10. We have 6 hundredths, and for 12 we have the probability 4 hundredths. So the question is, what is the probability that 8 or more laptops will be demanded in a particular day? So again, what is the probability that 8 or more means 8 greater than 8 and greater than 8? So 8 or more laptops will be demanded in a particular day. So how do we do that? How do we get the probability of getting 8 and or more laptops in a particular day? Letter B, what is the probability that the demand will be at least 7 but not more than 10 laptops? And letter C, what is the probability that the demand will be at most 9 laptops? So how do we get these probabilities? Okay, we will first answer the first question. What is the probability that 8 or more laptops will be demanded in a particular day? So solution. So our equation would be the probability that 8 or more laptops. So x is greater than 8 or equal to 8. 8 is greater than or equal to 8. So 8 can be, so 8 from 8, because it is equal to 8. We can have 9, because 9 is greater than 8, 10, up to 12. We cannot have 7 because 7 is less than 8. So we cannot have 7, 6, and 5. So we will have 8, 9, 10, and 12. So here are the random variable, the values of random variable. Next, what shall we do? So this means that we have to add the probabilities of the random variable 8, 9, 10, and 12. Simply add the probabilities of these values. So, our equation, probability of x which is greater than or equal to 8 is equal to the probability of 8 plus the probability of 9 plus the probability of 10 plus the probability of 12. Then simply substitute the probabilities for each variable or for each probability. So the value of the probability of 8, the probability of 8 is 18 hundredths. The probability of 9 is 25 hundredths. And the probability of 10 is 6 hundredths. And the probability of 12 is 4 hundredths. So we simply add these probabilities to get the result. And if you have your own calculator, you can do it, or you can do it manually. So as a result, the sum is equal to 53 hundredths. So therefore, the probability that 8 or more laptops will be demanded in a particular day is equal to 53 hundredths, or simply 53%. How do we get 53%? You simply multiply 53 hundredths by 100 and add the percent symbol. Okay, next question. Let us answer question number 2 or letter B. What is the probability that the demand will be at least 7 but not more than 10 laptops? So at least 7 but not more than 10 laptops. So how do we express that mathematically? So we have here the probability, since we are getting the probability. So the probability of x is greater than or equal to 7 because we have the word here at least 7. So the lowest number is 7, but not more than 10. So we have here x is greater than or equal to 7, but less than or equal to 10. So we only have from 7, the lowest number is 7 because we have the given at least 7. At least means this is the lowest number. So at least 7, but not more than 10. So at least 7, but not more than 10. So 7 is included and 10 is included. So we only have from here down to here. So we will get the probabilities. Okay, so we have here, how do we get the probabilities of that the demand will be at least 7 but not more than 10 laptops? So we have, this means that we have to add the probabilities from the probabilities of x when x is 7, x is 8, x is 9, and x is 10. So simply follow this formula. So P probability of 7 plus probability of 8 plus probability of 9 plus probability of 10. So simply substitute the values for each probability. So the probability of 7 is 1500s. The probability of 8 is 1800s. The probability of 9 is 2500s. The probability of 10 is 600s. And if you're going to add these four probabilities, the sum is equal to 6400s. Therefore, the probability that the demand will be at least 7 but not more than 10 laptops is equal to 6400s or 64%. So again, how do we get the 64%? Multiply the 6400s by 100. So that is equal to 64, and simply add the percent symbol. Okay, next. The last question. What is the probability that the demand will be at most? We have here at most 9 laptops. So at most 9. At most. When we say at most, the highest value is 9. So the greatest value or the highest value is 9 at most. So it is only until 9. So how do we represent at most 9? So we have the P of x. So the probability of x, which is less than but and equal to 9. So x is less than but and equal to 9. Less than and equal to 9. Less than or equal to 9. So meaning at most 9. 9 is the highest value. So we have here from 5. So we have here from 9. Since 9 is the highest value because this is already at most. This is the highest value. So from 9 going down to 5. So we have here the values of x. So this is x. X is greater than, x is less than, I mean, or equal to 9. So 5 is less than 9, 6 is less than 9, 7 is less than 9, 8 is less than 9, and 9 is equal to 9. So This is our mathematical equation. Now, how do we get the probability that the demand will be at most 9 laptops? So, this means that we have to add the probabilities of 9, the probabilities of 8, the probabilities of 7, 6, and 5. So, the probability of 9 is 25 hundredths. The probability of 18, the probability of 8 is 18. The probability of 7 is 15 hundredths. Probability of 6 is 12 hundredths. The probability of 5 is 20 hundredths. We're going to get the sum. Simply add the probabilities and you will get 90 hundredths. Therefore, the probability that the demand will be at most 9 laptops is 90 hundredths or 90%. Clear? Do you understand? Okay. So explore this. Example number 2, we'll have example number 2 for you to understand better. So tardiness. The recorded tardiness. So by the way, what does tardiness means? It means you're late. So you are slow in moving. That's why you're late. So the recorded tardiness of the students as reflected in school form 2 of the advisor is presented in the following probability distribution. So X is the tardiness, the number of tardiness of the students. So X we have here 0, 1, 2, 3, and 4. And we have there the respective probabilities. So for 0, we have 3/10. For 1, we have 2/10. For 2, you have 2/10. For 3, you have 2/10. And for 4, you have 1/10. Now we have the question there, what is the probability that the number of tardy students is greater than or equal to 3? By the way, so the x, the random variable here refers to the number of tardy students. Tardy, not the recorded tardiness, but the number of tardy students, those students who have tardiness, or those students who are late. So it's greater than or equal to 3. The next question, what is the probability that the number of tardy students is at least 3? And letter C, what is the probability that the number of tardy students is greater than 1 but less than 4? So we have here question letter A. The first question, what is the probability that the number of tardy students is greater than or equal to 3? Greater than or equal to 3. So how do we represent that in a mathematical equation? So the probability, since we are getting the probability, so the probability of x, which is greater than or equal to 3. So x is greater than or equal to 3. So we have here, so if x is greater than or equal to 3, we have the values p of 3 and p of 4 because we only have what are the values of x which are greater than 3 or equal to 3. So we have 3 and 4. We only have 3 and 4. We cannot have 2 because 2 is less than 3. It does not satisfy the equation. And the given is it must be greater than or equal to 3. So we only have values of 3 and 4. So what is the probability of 3? So we have 2/10 and the probability of 4 is 1/10. Get the sum, simply add the probabilities and you will get 3/10. Therefore, the probability that the number of tardy students is greater than or equal to 3 is 3/10, or you can write it in a decimal form or express it in percentage. So we have 30%. So 3 divided by 10 is 30. So we have 30%. So we have here the next question. What is the probability that the number of tardy students is at most 3? So we have here the probability which is at most 3. So it means that the value of x, 3, is the highest number. So if 3 is the highest number, then we will have values of 2, 1, and 0, because we have at most 3, where 3 is the highest number or highest value of x. So to express that in a mathematical notation, so we have here the probability of x which is less than 3 or equal to 3, because we have 3 as the highest number. So 3x is less than 3 or equal to 3. So we have here values of 3, 2, 1, and 0. So what is the probability of 3? We have 2 tenths. For 2, we have 2 tenths also. For 1, also 2 tenths. And for 0, we have 3 tenths. So we simply add these probabilities. By adding, we will get 9 tenths. Therefore, the probability that the number of tardy students is at most 3 is 9 tenths or 90%. The last question is, what is the probability that the number of tardy students is greater than 1 but less than 4? Again, so we have here greater than 1 but less than 4. So how do we express that mathematically? So we have there the mathematical notation. So x is greater than 1 but less than 4. So what are the values of x which are greater than 1 but less than 4? So from our values, we only have 2, 2, and 3. So it is between 1 and 4. 1 and 4 are not included because our x is greater than 1. So 2 is greater than 1, 3 is greater than 1, and 2 and 3 are less than 4. Okay, so what is the probability of 2? So the probability of 2 is 2 tenths, and the probability of 3 is also 2 tenths. So we simply add the two probabilities and we will get 4 tenths or 2 fifths. So therefore, the probability that the number of tardy students is greater than 1 or equal but less than, sorry, this is greater than 1 but greater than 1 but, so this is this is an error. So the probability that the number of students is greater than 1 but, but you simply write but less than less than okay, I'm having because I am using a cursor. So therefore, the probability that the number of tardy students is greater than 1 but this is not or but less than 4 is 4 tenths or 40%. When you divide 2 by 5, you will get, so the answer is 40%. So we will proceed. I hope you have learned from our discussions. If you find having difficulty in understanding, you can still replay, pause, and play from our previous discussion. So always be mindful of our general directions. So activity proper, answer the following exercises found in your learning activity sheets and show your solution. So you have there in your activity sheets exercise 1, which is all about the SAP social amelioration program. Exercise 2 is all about cell phone units sold in the time of pandemic. And we have there the reflection. This will be written in your journal notebook. So please write your answers in your journal. So from head, heart, bean, and bag. So this is our SOP. Okay, this is the end of our lesson for this time, lesson 5. So I hope you will do your task and you have learned a lot from this. Again, do not cheat, do not before looking into the answer key, answer all the activities first before checking your answers in the answer key. And please check your own work for you to be able to know if you are really learning or not. Okay, thank you.